Hello, class. Welcome to our next lesson dealing with section 4.6. We're going to be looking at some example questions about counting principles based upon what we talked about in the previous class hour. So let's go ahead and get started with kind of some base examples to make sure we refresh a few things. First one says, how many ways can you choose 5 people for a team from a group of 12? So this means order doesn't matter, which means it's combination. This should be 12, choose 5, and you should be able to plug that into your calculator and get 792. Arrangements for the word in Lafayette. Okay, remember that that's how many letters factorial, which would be 9 factorial, and just basically whatever has double, triple, quadruple count of the letters, you just divide by that factorial. So there's 2 A's, 2 E's, and 2 T's in the word Lafayette, and you would divide by that, and you should end up with 45,360. Again, the big thing here is show a setup, and then make sure that you can plug into your calculator right to find the final answer. The next one, how many ways can you put 10 people in a line? There's 2 ways that you can do that. That's a permutation of 10 and then permutation 10. You could do it that way. You can also arrange people in line using the factorial button, and that would be 10 factorial. And you'll get the number that's just over between 3 and 4 million, okay, in terms of that. That number's there on the screen for you. The menu options should just be fundamental counting rule or principle. And then that's just 5 times 8 times 4 for main course, side options, and dessert, which would give you 160. If you already know what dessert you want, that just eliminates the desserts essentially. So that would be 5 times 8, which would be 40. And if I already know what main course I want, that eliminates that as well. And that would just be the 8 side options. And that would just be 8 as a final answer. Technically, it's 8 times 1, but you won't have to write the times 1 in terms of those situations. Okay, the word Indiana should have 7 factorial ways, but you have to get rid of the double counts. So there's 2 I's, 2 A's, and 2 N's. So you divide by that, 2 factorial 3 times. And you should end up with 630 different passwords you can make with the letters from Indiana. What if the word had to start with D, though? Essentially what you're doing is saying you're forcing D to be in this first spot. That leaves you with 6 spots left, so that's 6 factorial now. Divide by still 2 factorial for the I's, A's, and N's. And so that eliminates options and makes it 90. If you want the probability the word starts with D, you figure out how many words start with D divided by the total, which would be 90 out of 630. This simplifies down to 1/7. Now this brings up a very interesting point. Because really, if you said, what's the probability the word starts with D, all you have to know is how many letters there are, which is 7, and how many are the letter D, which is 1. And so there's kind of a shortcut to this situation specifically because there's just 7 letters, and you say, okay, well, there's 1 out of 7 that's the letter D, which would give me the answer of 1/7. So there's 2 ways to get to that final answer. Your book's probably going to focus on what we just mentioned with the factorial pieces, but also realize logically it has to be 1 out of 7 because one of the 7 letters is the letter D. The next one, 3-digit numbers, typically digits, there's 10 digits. Don't forget 0 is a digit, so 0, and then 1 through 9 would be 10 options. You're going to have some questions that sometimes kind of limit that, so you'll notice that I'm only picking from these 7 options. For whatever reason, the other numbers aren't being used. How many 3-digit numbers are possible? Well, it's just 7 times 7 times 7 because they can repeat themselves. So this is a fundamental counting principle idea. So 7 times 7 times 7 would be 343 different options. What if I want it to be divisible by 5? How many different options are there? Well, there's the only rule for divisible by 5 is the last number has to be a 5 or a 0. So it's still 7 times 7 because that's irrelevant. But then 2 options because there's the 5 and the 0 that could be the last number, which would be 98. Finding the probability that you get a number divisible by 5, well, it would just be the 98 divided by the 343 we found, which is 2 7s. Which also makes sense because none of the numbers matter except the last one. And you say, well, how many of the last numbers? Oh, well, 5 and 0 makes 2 of the 7 numbers that would be possible for division by 5. Okay, the next thing that we're going to look at is a more complicated version of a combination question. This is a good example of style of question that will look that you will look at a lot, especially when we get to some of the card counting type situations. So there's 6 girls, 4 boys trying out for the 4-person math team. I want to find the probability that I pick 2 boys and 2 girls on the team. Most importantly, order doesn't matter that you were picked. And so the easiest way to find this answer is to first off figure out the total number of ways you could just pick from the 10 people, 6 girls, 4 boys. There's 10 people total. and find the 4-person math team. So you'll notice the denominator is combination of 10, choose 4 people. Okay, that's going to be the same in most questions like this. The numerator, though, takes each subgroup and says, how many of each subgroup do you want? Okay, so for this question, there's 6 girls to choose from, and I want 2 of them. There's 4 boys to choose from, I choose 2 of them. Okay, and all you're saying is, I want to make sure we separate the groups and say, of the girls, I want 2, and of the boys, I want 2. So that's just 6 choose 2 and 4 choose 2, and you just multiply all that together and divide by the total. And you end up with 3/7 as an answer, or 0.429. Anytime there's a combination scenario and there's subgroups, you're going to have to go this route. The combination piece has already dealt with the fact of the ordering, so you don't have to worry about the ordering aspect of this question. But you do have to make sure that you're able to multiply the pieces together for the numerator, and the denominator will be everyone in one big group, as opposed to separated out to figure out how many are needed from each group. The next one says find the probability at least one girl is on the team. Well, it's easier to figure out its complement and subtract it. So instead of figuring out at least one girl, that would mean I'd have to figure out how many ways that one girl could be on the team, 2, 3, or 4. That would require 4 different combination situations to find the answer. Instead, if I see at least one, I'm just going to do 1 minus its complement, which would be there's no girls on the team. So if there's no girls on the team, that means of the 6 girls, I choose 0. Of the 4 boys, all 4 of them are on the team. And the denominator is still 10, choose 4, because that's just always how many different options are there, regardless of restriction. That would give me 1 minus 1 out of 210. And if I subtract that out, I'll get 209 out of 210. Which, think about it, that makes a lot of sense. It should be very likely at least one girl's on the team, because there's 6 of the 10 to choose from that are girls that are possible to join the team. This question is probably a fraction question rather than a decimal question. If it was a decimal, you would just have to find that and round to the appropriate decimal point, or place, excuse me. The next question deals with the game of Yahtzee. So let's first talk about the game of Yahtzee. If you don't know what we're talking about, the game of Yahtzee is 5 dice and you roll them. Now you get more rolls and things like that. You get 3 rolls typically to figure out what you're going to do. We're trying to say what's the probability you get a Yahtzee, which is a 5 of a kind, all 5 the same number on one roll. So let's just look at rolling 5 dice and getting a 1 on all of them. If I want to get a 1 on all of them, okay, I'd have to get a 1 on each die, which is a 1 out of 6 probability. So 1 out of 6 times itself. Basically, 1 over 6 to the 5th power, which becomes 1 over 6 to the 5th, which I'm not going to find that number yet, because I am just saying what's probably going to get a Yahtzee. Well, I could get that 1s, 2s, 3s, 4s, 5s, or 6s as an answer. So I need to multiply because there's 6 ways to get the Yahtzee. And that would be 1 over 6 to the 4th now, which is 1 over 1,296. It's very unlikely that that occurs. If you've played Yahtzee growing up, you've probably had that happen at least once with all the different dice rolling that you've had. But when it comes to the game, okay, Yahtzee is 5 of a kind, and we're just saying probability in 1 roll. So that's why I just did 1/6 times itself over and over again. But there were 6 ways to do that. And that's the piece that is added in that may be a little bit confusing as you get started. The next question deals with phone numbers. We're not looking at area codes right now, so phone numbers in the U.S. are 7 digits long. How many different phone numbers are possible? Well, there's 10 digits. Remember, don't forget to include 0. So 0 and then 1 through 9, there's 10 digits. So each spot should have 10 options. That's what this is saying. 10 times 10 times 10 times 10, because you could be any of those numbers. The problem is the first number can't be a 0 because that goes to an operator historically. And it can't be a 1 because 1 is like 1-800 to show like a different area code or even maybe a different area of the world. And so the area code idea is where we deal with some of those pieces, and 1 is what separates that. Phones now are kind of embedded with this 1 dash, but old 1-800 numbers, you had to type 1 first and then the area code. That's less of an issue now. Because it kind of is programmed to put that 1 in front for you. But there would be 8 million different phone numbers that are possible in every area code. There's probably a little bit less than that. For example, your number can't start with 911. They're not going to give you 8675309 because of the song, for example. So it's probably less than 8 million. That's just giving us a base case. But there's going to be a little bit less as you move forward if you really get into the number system. If we run out of numbers for phone numbers, which I guess is possible depending on the situation, one thing that's helped with that is using extensions. So like here at school, we have like 2 phone numbers that come to the school, and then each teacher has an extension. That's a lot easier than giving each of us our own phone number. The other thing is if we run out, we'll just add a number at the end. We'll just put a number at the end, and all of us that have current numbers, we just add a 0 to the end of all of our numbers, and then other people would have to add different numbers to the end of their phone number. Okay, the word question. How many 3-letter words? Now remember, words is not real words, it's passwords with no vowels. So remember, A, E, I, O, U are vowels for what we need. So if there's no vowels, I need to pick from the 4 consonants and choose 3 of them, but the order matters. So that's a permutation of 4 permutation 3. Probably writing it this way, P parenthesis 4 comma 3, and then end the parentheses, probably the easiest way to show it on a computer. And that would be 24 different ways to make 3-letter words that have no vowels based upon the letters in the word question. How many 5-letter words with 3 different consonants and 2 different vowels? This is similar to the idea of the boys and girls with separating them out first. So there's 4 consonants. I need 3 of them, but it's combination right now because I just need to choose the letters. And then of the 4 vowels, choose 2 of them. What that does is say, how many different ways can I choose the letters that are being picked? And then I multiply by 5 factorial because once I pick the 5 letters, there's 5, 4, 3, 2, 1 ways to arrange those letters. So the main takeaway from that question is I need to choose the letters first. So I do the combination idea just to choose the letters, and then I multiply by the ways to arrange them. That's a different level of just choosing them. So you want to make sure you pay attention to that example in terms of the choosing idea to figure out which letters you're going to choose, and then multiply by 5 factorial for the 5 factorial ways to arrange those letters. This 5-person committee, this is what we were just looking at with the boys and girls as well. How many ways can I have 3 men and 2 women on the committee? The numerator would be 7 men choose 3, 6 women choose 2, and so that would be the numerator. I would multiply that together. The denominator, remember, has no subgroups. So there's 13 people because 7 men, 6 women, so that'd be 13 people to choose from, and I want to be a 5-person committee. Notice here that a byproduct of this type of situation is 7 plus 6 is 13, 2 plus 3 is the 5, and so that situation could be helpful as you're going through a question like the committee problem because the numerator should kind of add up to the denominator. That didn't work as well with this situation because I wasn't finding a probability and I had to deal with the ways to arrange them. If it's a combination situation, that should always work that way, and card counting would be a similar idea as we look at that. And so the probability you would have 3 men and 2 women on the board would be just over 40% at 0.408. Typically, we're going to go 3 significant digits. Okay, so if there's zeros leading up to it, and then 1, 2, 3 numbers after that in order to find that answer. Okay, that is a lot of different pieces of information about the counting principles. You want to make sure that you're looking at some notes with that and how to set those up and find those answers. Make sure you know how your calculator works, how to deal with factorial, how to deal with permutation, how to deal with combination, and how to show a setup and then write the answer in a decimal or a fraction format. Have a good day, everyone.